Okay, this is part 4 of my series on assembling the circuit boards for the John Linsley-Hood K1450 phono preamp. This covers inserting the capacitors, which is the last stage of the board assembly. Now the capacitors used in this are, as specified in the original design, they're either a combination of plastic film in parallel with an electrolytic for larger values, or a polystyrene capacitor for lower values. Polystyrene is an excellent dielectric. It's about the best thing you can use for audio circuits. It's the extreme opposite of multi-layer ceramics, which are absolutely terrible for coupling capacitors and should never be used in audio, but a lot of cheap stuff does use them. The reason for that is some ceramics are piezoelectric. They generate a voltage when moved or flexed, or vibrate when the voltage across them changes. Notice they can act like microphones or resonators. Anyway, back to the topic. That is C2, which is a 1 microfarad. It's a plastic film, which will eventually be in parallel with C1 when that's fitted. I've already fitted the 0.1 microfarad capacitors, the 100 nanofarads, in the previous video, as I use those as a height gauge for installing the transistors, just to give a better overall appearance. They just happen to be a convenient height to set the transistors to. That's a board that's got all the capacitors in, and if I go in order, that 1 microfarad there is the first one, and then the polystyrene capacitors, the little square ones, are the next. I'll go through those in order of value. So there are two 220 picofarads, which are C4 and C15. Those two locations. Bending leads a bit more than 45 degrees to hold them in place until they're ready for soldering. The next two is the next one is a 680 picofarad. That is C19. That's up there. Then C17 is a 1 nanofarad, 1000 picofarads. And the last one in the bag. C17 there. Now these don't look much like traditional polystyrene capacitors, but they are exactly the same type of capacitor, just with the lead folded back down and in an outer casing which makes them take a lot less room on the circuit board. They'll also be very stable. If you try to mount a conventional polystyrene on end, it would look rather messy and it would probably be a rather unstable thing on the circuit board. Put my hands on some. Just to demonstrate. These are what most people think of when they hear about a polystyrene capacitor. Little silver looking axial lead things, or that style in different sizes. And they take either a lot more circuit board space, or if you mount them on end, they're a bit fragile. So this style, which is readily available from several suppliers, is a lot nicer to use for something like this. It keeps the space down, there's no bare wires sticking out the top, and just generally convenient. Okay, next one is C18, which is a 2.2 Nanofarad, 2200 picofarads. And again, the last one in the bag. That's that. And the last of the polystyrenes is a 10 Nanofarad. It's fractionally bigger, which is C3 over that side. But I won't actually fit that yet because that's a bit taller than the electrolytic capacitors. I'd rather fit those whilst they're easy to get to. So those are 100 microfarads in most positions and a couple of 470 microfarads. These are some of the 100s. I need another bag out. There are 6 of those. So parts list. Positions are C1. The longest lead is normally the positive lead, and also the symbols have a plus sign at one side and the bar at the other side, which represents the bar on the capacitor, depending which mate you get. Usual bend to hold it in place. So C5, C6, C9, C10, C20, and I miscounted, there are 7, not 6. C22. Now the capacitor I'm using though is 100 microfarad 63 volt, which they don't need to be anything like that. They only run at 15 volts at most, and some of them only at 5 volts. But the capacitor lifespan is proportional to percentage of its maximum ratings, or should I say inversely proportional. If you run them at lower voltage, lower ripple current and lower temperatures, the life expectancy goes up exponentially. If you think a normal capacitor often has a rating of only about 2,000 hours, which is about 3 months, you don't want to run them at full ratings. So being underrun in every way means they should last just about forever in this type of use. And these are the two 470 microfarads, which are also overrated a bit at 25 volt. Normally run at 5 volts or less. Also, again, they are all high ripple current rated ones, a relatively high ripple current, and the ripple currents are tiny. So they are being underrun by a massive amount for long-term reliability, and all being shunted by plastic dielectric capacitors. The loading on them will be minuscule. Okay, so that's all the electrolytics and the polystyrenes in, and that one-odd plastic film there. Now they're all about the same height, so I'm going to solder all those first and then fit the last 3. Again, I'm working on a piece of folded kitchen towel which just acts as a bit of a spring. It helps keep things in place and avoids scratches. It's just more pleasant to work on than a completely hard surface. I tend to press down with a spare finger just to steady the board and also keep the pressure on the soft surface to help stabilise the components I'm fitting, or soldering should I say, and keep them seated fully in if the Bentleys don't hold them quite tight. Again, the lighting is set up for the camera, which means it's not that brilliant for me at this angle. So just have to double check where some of the joints are. Make sure I've got them. Because from this angle it's difficult to see the difference between a hole with a trimmed lead and an empty hole. Just holding that one at my fingertip so it's not hanging away from the board because it's in midair. And that's all the electrolytics, I believe. Yeah. And the polystyrenes. With those done, there's that one last taller polystyrene capacitor and then two much larger plastic film. In fact, I think I'll do the plastic film first, as I believe they're a little bit shorter than the polystyrene. There's not a lot in it. All the part numbers for the capacitors are on the parts list. That's giving RS part numbers, RS components. You can cross-reference the manufacturer's part numbers from there if you wish. That's those two, 2.2 microfarads in C16 and C24 positions. And finally, that slightly taller polystyrene, which is 10 nanofarad in C3 position. Okay, that's board complete, ready for testing. Obviously, if you're building a stereo preamp for use with a record deck, then you need two, and you need a power supply of around plus or minus 15 volts DC, which I also have a circuit board for, to power them. There are a couple of positions, you know, they've got empty holes, J1 and J2. Those are the gain select jumpers, I'll show on the schematic. The default configuration with those open is the gain is set to match a common moving magnet type phono cartridge, pickup cartridge. With them closed, it increases the gain drastically and changes the input impedance to match a moving coil cartridge, which are relatively scarce. Some people claim to be high quality. That's J1 and J2 on the schematic, which, as you can see, are marked moving magnet or moving coil, and closed means moving coil. But if you're using with a normal moving magnet pickup, you can just ignore those. If you have a moving coil, then just put little wire loops in and solder those. Or you could fit 2-pin headers and put jumper caps on, but it's very unlikely you'd be switching between the two, so normally I'd say build them either with open holes or solder links, just to avoid any chance of bad connections in the future on the jumpers. All being well, those should now be identical to the previous ones. More information and example audio files, just short clips from numerous LPs made using some of these boards, some of the prototypes, are on my website, and that is robert-jenkins.co.uk. And thanks for watching.